Hi, and thanks for watching this video, which is about my 6502 homebrew computer and some new features that I've added to the machine in the last few weeks. I've got three things that I wanted to show you in this video. One is changing the boot up sequence and behavior. Another is around the SD card and the detection of that. And finally, to talk about the real-time clock and accessing some of the features of that, which I think is probably the most interesting part. So we'll get onto that as quick as possible. Firstly, on the keyboard, before, when the homebrew computer would fire up, if I didn't have the F1 key held down on reset or switch on, the computer would go into serial I/O mode by default, which is a pain if I'm not expecting that. And also in MAME, it's a little bit annoying because you have to obviously reset the machine and do the F key. So just for convenience, I've now changed the approach so it boots up in keyboard mode. But how does the machine know a keyboard is connected? Well, on the BBC keyboard, there are some dip switches. And what the boot code does now is it checks the status of these dip switches. When the keyboard is not connected, when I'm debugging sometimes I haven't got the keyboard connected, then these dip switches do not read a value. In fact, they just read back as all ones because I've got a weak pull-up on the keyboard sense pin. So they read as all ones, so FF, and or hex FF. So if it reads hex FF, it assumes there is no keyboard, and then it goes into the defaults of serial I/O. If the dip switch is something other than FF, then it assumes the keyboard is connected, and then it uses, it doesn't need the F key, the F0 key anymore, but I can still use the F1 key to force it to go into serial mode anyway. But anyway, that should make it just a little bit easier to use under MAME emulation as well. No need to remember to press the F key on startup. The second thing is you'll note that the SD card has been initialized and the file system has been mounted, and so I can do directory listing, etc. All very good. But sometimes, and again under MAME especially, you have to mount the SD card image after you've started the MAME machine image. So the previous boot code would sit there trying to initialize the SD card, and it would lock up. And in the real hardware, the same thing would happen if the SD card wasn't plugged in. So I've decided to change that to make it, again, a convenience feature. So I'll pop the SD card, and then if I now reset the machine, what we'll see now is I just get a message saying bad or missing SD card, but at least the machine boots up, so I can still do something even for demo purposes. So that's helpful, as I say, because of the way that MAME boots up. So I'll put the image, the SD card back, and reset the machine again, and we're back to normal. Now the final thing then is the SD, not the SD, but the RTC, the real-time clock. You'll remember that the real-time clock, so it's behind this keyboard interface here. You can see a coin cell battery, which basically provides the backup or the charge for the real-time clocks, date and time keeping. But these real-time clocks also have non-volatile RAM. So the first 14 locations 0 to 13, are for the real-time clock's own uses for timekeeping, but locations 14 onwards are available for user storage. So I have added a new command called nvpeak and nvpoke to read and write these locations. So if I, for example, try to print out the value in location 14, I'll see there's a 0 here, and what that means is in this system that I would like to boot up in normal screen mode. So typically when the homebrew boots up, it's in 40 color mode, and the screen is in magenta background and white foreground. The video, because of the angle of the video camera and the screen, it doesn't look very magenta, but you can kind of see it's magenta. It seems to be blue on the right hand side, but that's just artifacting. So that's the default mode, and location 14 is what what screen mode to start up in, because I also have, so mode 0 is the text mode, 40 columns. Mode 1 is the 32 column mode. So if I well, I'll do a directory listing, and you can see, because I've optimized directory listing for 32 column 40 column mode. In 32 column it's a bit of a mess, but the point is that location 14 gives me this ability to override. So if I was to NV poke location 14 with 1, so now let's just print out value of NV peak 14, we can see it is 1. And the interesting thing is now is I will do a hard switch off here to prove it. If I switch it off, so it's all off, no signal. Obviously what's happening here is that the battery backed RAM is maintaining its contents, and I'll switch it back on, and the LEDs have started again, and it's booted into mode 1, and that's because of NV RAM location 14. And in fact, let's print out the value of NV RAM 14, and it's 1. So even through a switch off, so this is pretty cool. It means I'm able to have some permanent settings that the operating system can use for certain preferences, in this case what screen mode. So let's go back to screen mode, NV RAM poke, NV poke 14,0, and if I reset now, go back to the default 40 column mode. Now the other thing that's always nice to be able to do is change the default colors. I quite like this magenta, but others may not. So the second location provides me the ability to override the default colors. Now if I look at location 15, it's 0, which means use the ROM's default, which is the color that we see here. However, in normal B flats, I can change the foreground and background. So let's say I wanted white on red, that's 15 and 6, so color register 32 is the foreground background color register, and there we go, it can do that. But if I reset the machine, it's back to magenta. But let's poke, I keep saying poke, I mean NV RAM poke, which is NV poke, location 15 with the hex value of that register. The first nibble is the foreground color, so that's F, and the second nibble is the background, which is 6, and that's red. It's done that. I'll print that out, print out the value in a moment, but basically if I reset now, I'm sure you'll be able to see what to expect, which is a red background. And now it's gone widescreen here just because of the way the TV is synced on the signal, but that's not a setting that I've picked. But if I look at NV peak of 15, you can see that's the decimal value of hex F6. So that's pretty cool. I've got some ideas about other things I can store in non-volatile RAM, because there are probably other things that I would like to have as settings that I can retain between sessions and power up power cycles. So screen mode and color. I'm also thinking about things like the repeat speed of the keyboard, one or two other little features. I don't know, I'll think of a few more, but yeah, that's my update. Nearly at 10 minutes, sorry about that, but thank you very much for watching this video.